Most people believe that vision loss and memory decline are simply unavoidable parts of aging. Something written into our genetics, something that slowly creeps in no matter what we do. Eyes become weaker, focus fades, names slip away, concentration shortens, and we are told this is normal. But the human body was never designed to fail quietly. Inside you right now are powerful biological repair systems that respond every single day to what you eat, especially in the hours before sleep, when the brain cleans itself. The eyes regenerate light-sensing cells, and the nervous system rewires memory pathways. What you choose to feed your body before bed can either interrupt this healing process or amplify it dramatically. Modern science now shows that the brain and the eyes are not separate organs working alone. They are deeply connected through blood flow, inflammation control, antioxidant defense, and mitochondrial energy production. When these systems are nourished correctly, visual clarity improves, night vision sharpens, mental fog lifts, and memory circuits strengthen. When they are starved or inflamed, degeneration accelerates quietly. The most surprising part is that some of the most powerful nutrients for this repair are not exotic supplements or expensive treatments. They are ancient foods that humans have relied on for thousands of years, concentrated, natural, and biologically active. Dry fruits, when eaten strategically, act like nutritional signals. They communicate directly with your blood vessels, your neurons, and your retinal cells. At night, your body shifts into repair mode. Blood pressure lowers, cortisol drops, and the brain activates a cleansing system that removes toxic proteins linked to memory decline. During this window, certain nutrients cross the blood-brain barrier more efficiently and reach the delicate tissues of the eyes more effectively. This is why timing matters just as much as what you eat. Inside the retina, light-sensing cells are constantly exposed to oxidative stress. Blue light, screen exposure, pollution, and even normal daylight generate free radicals that slowly damage vision over time. Meanwhile, in the brain, memory depends on the strength of synapses, the tiny connections between neurons. These synapses weaken when inflammation rises and blood flow decreases. What research now reveals is that specific plant compounds can protect these cells, restore circulation, and activate natural growth factors that support learning and recall. Before bed, the body becomes especially responsive to minerals like magnesium, zinc, and potassium, and to antioxidants such as polyphenols and flavonoids. These compounds reduce nighttime inflammation, stabilize blood sugar, and support deep sleep, which is when memory consolidation happens. During deep sleep, the brain literally replays information from the day, strengthening important memories and discarding unnecessary ones. If the brain lacks proper nutrition during this phase, that process becomes inefficient. The eyes follow a similar pattern. At night, retinal cells repair microscopic damage accumulated throughout the day. Blood vessels supplying the optic nerve relax and reopen, improving oxygen delivery. Nutrients that support nitric oxide production, collagen stability, and nerve signaling become crucial during these hours. Dry fruits, despite their small size, are dense sources of exactly these compounds, packaged in a form the body recognizes and absorbs easily. What makes this even more remarkable is how these foods influence the immune system. Chronic low-grade inflammation is one of the main drivers of both vision deterioration and memory loss. Certain natural compounds calm overactive immune responses, allowing tissues to heal instead of being attacked by the body's own defenses. This immune balance is essential for preserving sharp eyesight and mental clarity over the long term. There is also a vascular connection that cannot be ignored. The brain consumes about 20% of the body's oxygen, and the eyes are among the most blood-hungry organs in the body. Anything that improves circulation improves function. Some nutrients gently widen blood vessels, making it easier for oxygen and glucose to reach neurons and retinal cells. Over time, this improved flow translates into clearer vision, faster thinking, and stronger recall. What you are about to hear is not about instant miracles or exaggerated promises. It is about understanding how the body heals itself when given the right signals at the right time. These dry fruits work quietly, consistently, and naturally, supporting the very systems that keep your mind sharp and your vision clear. When eaten before bed, they align with your body's internal rhythm, enhancing repair instead of disrupting it, working with biology rather than against it. Nighttime is not just a pause between days. It is the most biologically active healing window the human body has. As the lights go off and the body prepares for sleep, a powerful internal switch flips. Stress hormones like cortisol begin to fall, heart rate slows, and blood pressure gently drops. This creates the ideal internal environment for repair. During these hours, the brain and eyes shift away from processing information and toward restoring damaged cells, clearing toxins, and strengthening neural connections. What most people don't realize is that this repair process is highly sensitive to nutrition, especially what is consumed in the final hours before sleep. The brain has a remarkable self-cleaning system that becomes most active at night. Cerebrospinal fluid flows more freely through brain tissue, washing away metabolic waste products that accumulate during the day. Some of these waste products are directly linked to memory loss, cognitive decline, and slower thinking. If this nightly cleansing process is disrupted by poor nutrition, unstable blood sugar, or inflammation, the brain wakes up less efficient than it could be. On the other hand, when the right nutrients are present in the bloodstream, this cleanup process becomes more effective, allowing neurons to function with greater clarity and speed. At the same time, the eyes are undergoing their own restoration cycle. Retinal cells, which are constantly exposed to light and oxidative stress, rely on nighttime repair to maintain sharp vision. During sleep, the optic nerve experiences improved oxygen delivery and damaged cellular components are recycled. Antioxidant availability during this period plays a crucial role in determining how well these light-sensitive cells recover. Without sufficient protection, microscopic damage accumulates over time, leading to blurred vision, poor night vision, and increased eye strain. Blood sugar stability is another critical factor during the night. Sudden drops or spikes in glucose can trigger stress responses that interrupt deep sleep and impair brain repair. When the body has access to slow-releasing nutrients before bed, it maintains a steady energy supply to the brain without activating stress hormones. This allows the nervous system to remain calm, promoting longer periods of deep sleep, which is when memory consolidation takes place. During this phase, the brain strengthens important neural pathways, reinforcing learning, recall, and focus. The immune system also becomes more active at night, shifting from defense mode to repair mode. Inflammation that builds up during the day is addressed, damaged tissues are restored, and immune signals are recalibrated. Chronic inflammation is one of the hidden drivers of both cognitive decline and vision problems. Nighttime nutrition that supports immune balance helps prevent the immune system from mistakenly attacking healthy neural and retinal tissue, preserving long-term function. Circulation patterns change during sleep in ways that benefit the brain and eyes. Blood flow becomes more evenly distributed and vessels supplying critical organs relax. Nutrients that support vascular flexibility and nitric oxide production enhance this effect, improving oxygen and nutrient delivery to neurons and retinal cells. Over time, this improved circulation contributes to sharper visual processing and faster mental performance. Hormonal activity during sleep further amplifies the impact of nutrition. Growth hormone release peaks at night, supporting cellular regeneration throughout the body, including the brain and eyes. This hormone stimulates tissue repair, protein synthesis, and cellular renewal. When the body has access to the right micronutrients during this window, growth hormone can work more efficiently, accelerating recovery and strengthening delicate neural structures. Sleep itself is deeply influenced by what is eaten before bed. Certain nutrients promote relaxation by supporting neurotransmitters responsible for calmness and sleep onset. When sleep quality improves, the brain cycles more effectively through its stages, allowing for optimal memory processing and emotional regulation. Poor sleep, even in subtle forms, weakens attention, slows reaction time, and strains the visual system the following day. The connection between nighttime nutrition, brain repair, and eye health is not theoretical. It is rooted in how human biology evolved to synchronize eating, resting, and healing. When food choices align with this rhythm, the body responds by prioritizing restoration. When they disrupt it, repair processes become inefficient. This is why the final meal or snack of the day carries disproportionate influence over cognitive sharpness and visual clarity, quietly shaping how the brain and eyes function over time. Dry fruits may look small and simple, but biologically, they are dense packets of protective information for the body. Inside each piece is a concentrated blend of minerals, healthy fats, fiber, and plant-based compounds that directly influence how cells survive stress and repair damage. When it comes to the eyes and the brain, these nutrients act like shields and builders at the same time, protecting delicate tissues while supporting regeneration at the cellular level. This dual role is especially important for organs that are constantly active and highly sensitive to oxidative damage. The retina is one of the most metabolically active tissues in the human body. Every second, it converts light into electrical signals that the brain can understand. This process generates free radicals, unstable molecules that damage cellular structures if not neutralized. Dry fruits contain natural antioxidants that help stabilize these free radicals before they can harm retinal cells. Over time, this protection preserves visual sharpness, contrast sensitivity, and the ability to adapt to low-light conditions. In the brain, neurons rely on healthy cell membranes to transmit signals efficiently. Many dry fruits are rich in beneficial fats that support membrane flexibility and integrity. When these membranes are strong, communication between neurons becomes faster and more reliable. This translates into clearer thinking, quicker recall, and improved focus. Without adequate nutritional support, these membranes become rigid and vulnerable, slowing neurocommunication and weakening memory pathways. Minerals found in dry fruits play a critical role in nerve signaling. Magnesium helps regulate neurotransmitters that calm the nervous system and support learning. Zinc is involved in synaptic plasticity, the brain's ability to form and strengthen connections. Potassium supports electrical activity in both neurons and retinal cells. These minerals do not work in isolation. They function as part of a coordinated system that keeps neural circuits stable and responsive. Another powerful aspect of dry fruits is their influence on blood flow. Certain plant compounds help blood vessels relax, improving circulation to the brain and eyes. Enhanced blood flow means more oxygen and nutrients reach these tissues while waste products are removed more efficiently. Over time, this improved circulation supports sharper vision and sustained mental energy, reducing fatigue and strain. Inflammation is a silent threat to both vision and memory. Low-grade, chronic inflammation slowly damages neural tissue and accelerates degenerative processes. Many dry fruits contain natural anti-inflammatory compounds that modulate immune responses rather than suppressing them. This balance allows the body to heal without triggering unnecessary tissue damage. In the eyes, reduced inflammation protects the optic nerve and retinal layers. In the brain, it preserves the integrity of memory-related regions. Fiber in dry fruits also contributes indirectly to brain and eye health by stabilizing blood sugar levels. Sharp spikes and crashes in glucose can stress neurons and disrupt visual processing. Slow digesting fire ensures a steady release of energy, preventing metabolic stress that interferes with cognitive clarity and visual comfort. Stable blood sugar supports consistent focus and reduces nighttime awakenings that fragment sleep. Dry fruits also support the gut-brain connection. Compounds within them nourish beneficial gut bacteria, which in turn produce molecules that influence brain function, mood, and inflammation. A healthier gut environment leads to clearer signaling between the digestive system and the brain, reinforcing memory and emotional balance. This connection extends to eye health as well, as systemic inflammation often originates in the gut. What makes dry fruits particularly effective is their natural synergy. The nutrients within them are packaged together in ratios that the human body has adapted to recognize and utilize efficiently. This synergy enhances absorption and effectiveness compared to isolated nutrients. When consumed regularly, these foods provide consistent support for neural and retinal health, strengthening the body's resilience against daily stressors. Over time, the protective effects accumulate. Cells exposed to fewer free radicals, better blood flow, and balanced immune signaling age more slowly. Neural networks remain adaptable, and visual processing stays sharp. Rather than overwhelming the body, dry fruits work quietly in the background, reinforcing the systems that maintain clarity of sight and strength of memory, supporting long-term function through nourishment rather than stimulation. Vision and memory depend on a single, often overlooked factor that connects every system in the body: blood flow. The eyes and the brain are among the most energy-demanding organs humans possess, and they rely on a constant, uninterrupted supply of oxygen and nutrients to function correctly. Even minor reductions in circulation can quietly reduce visual clarity, slow mental processing, and weaken memory formation. Over time, poor blood flow does not announce itself loudly. It erodes function gradually, making people believe decline is inevitable when it is often circulatory in nature. Inside the brain, billions of neurons communicate through electrical and chemical signals that require energy every second. That energy arrives through the bloodstream in the form of oxygen and glucose. When circulation is efficient, neurons fire smoothly, networks synchronize, and information moves rapidly across memory centers. When blood flow is compromised, neurons struggle to maintain this activity, leading to mental fatigue, slow recall, and reduced focus. This is why improved circulation often produces immediate improvements in mental clarity. The eyes are even more sensitive to changes in blood flow. The retina contains a dense network of tiny blood vessels that must deliver oxygen with extreme precision. Any restriction can affect how light signals are processed, causing blurriness, reduced contrast, or difficulty seeing in low light. The optic nerve, which carries visual information to the brain, also depends on healthy circulation to maintain signal strength. When blood flow improves, visual processing becomes sharper and more reliable. Blood vessels themselves are living tissues that respond to what we eat and how we live. Inflammation, oxidative stress, and poor nutrition make vessel walls stiff and narrow, reducing their ability to deliver blood efficiently. Over time, this stiffness increases resistance, forcing the heart to work harder while sensitive organs receive less oxygen. This process contributes to both cognitive decline and vision problems, especially as people age. Certain nutrients have the ability to restore flexibility to blood vessels. They support the production of nitric oxide, a molecule that signals vessels to relax and widen. When nitric oxide levels are healthy, circulation improves naturally without forcing the cardiovascular system. Enhanced vessel relaxation allows blood to reach deeper into brain tissue and the fine capillaries of the retina delivering nutrients exactly where they are needed. Improved circulation also supports waste removal. As blood flow increases, metabolic byproducts are carried away more efficiently in the brain. This means fewer toxins interfering with neurocommunication. In the eyes, it means reduced buildup of damaging substances that strain retinal cells. Efficient waste removal keeps tissues cleaner, healthier, and more responsive. There is also a strong link between circulation and inflammation. Poor blood flow promotes inflammatory signaling, while improved circulation helps resolve it. When blood moves freely, immune cells receive clearer signals and can complete repair tasks without lingering in tissues unnecessarily. This balance protects delicate neural and visual structures from chronic immune-related damage. Sleep further amplifies the benefits of improved blood flow. During rest, circulation patterns shift to favor repair and regeneration. Blood vessels supplying the brain and eyes relax, allowing deeper penetration of oxygen and nutrients. If circulation is already compromised, this nighttime advantage is reduced. When circulation is supported, nighttime repair becomes far more effective, reinforcing both memory consolidation and visual restoration. Hormones involved in cognitive function and vision are also influenced by blood flow. Neurotransmitter production, hormone delivery, and receptor sensitivity all depend on efficient circulation. When blood flow is optimized, signaling between brain regions become more synchronized, improving attention, learning, and recall. Visual reflexes become faster, and eye muscles coordinate more smoothly. Over time, consistent improvements in circulation reshape how the brain and eyes age. Neurons receive better nourishment, synapses remain active, and visual pathways stay responsive. Rather than adapting to decline, the body adapts to efficiency. Clearer vision and sharper memory emerge not as isolated improvements, but as natural outcome of restored blood flow supporting every layer of neural and visual function. Inflammation is often misunderstood as something that only appears during illness or injury, but in reality, it can exist quietly for years at a low level, damaging tissues with obvious symptoms. This chronic, low-grade inflammation is one of the most powerful hidden forces behind both vision deterioration and memory decline. It slowly disrupts cellular communication, weakens protective barriers, and accelerates aging in the brain and eyes. Unlike acute inflammation, which helps the body heal, chronic inflammation keeps tissues in a constant state of stress, preventing proper repair. In the brain, inflammation interferes with how neurons communicate. Chemical messengers become imbalanced, synapses weaken, and neural networks lose efficiency. Memory formation depends on precise signaling between cells, and inflammation blurs those signals. Over time, this leads to forgetfulness, difficulty concentrating, and mental fatigue. Inflammatory molecules also increase oxidative stress, creating a hostile environment that damages neurons and reduces their ability to regenerate. The eyes face a similar threat. Retinal tissue is extremely delicate and highly sensitive to inflammatory damage. Chronic inflammation can weaken the protective layers of the retina, disrupt blood vessels, and strain the optic nerve. This often shows up as blurred vision, light sensitivity, eye fatigue, or reduced clarity, especially in low-light conditions. Because the eyes are exposed to environmental stressors like screens, pollution, and bright light, inflammation can accumulate faster if not properly controlled. One of the most damaging effects of inflammation is how it alters blood vessel function. Inflamed vessels become stiff and narrow, reducing blood flow to the brain and eyes. This creates a cycle where poor circulation increases inflammation, and inflammation further restricts circulation. As oxygen and nutrients become harder to deliver, tissues weaken and repair slows down, accelerating functional decline. Natural antioxidants play a critical role in interrupting this cycle. They neutralize free radicals that trigger inflammatory responses in the first place. By reducing oxidative stress, Antioxidants cause immune overreaction and allow tissues to return to a balanced state. This protective effect is especially important in the brain, where excess inflammation can damage memory centers, and in the eyes, where it can compromise visual processing. Inflammation also disrupts the blood-brain barrier, a protective filter that controls what enters brain tissue. When this barrier is weakened, harmful substances can pass through more easily, further increasing neural stress. Reducing inflammation helps preserve the integrity of this barrier, protecting neurons from toxins and maintaining a stable internal environment for cognitive function. The immune system's behavior changes significantly when inflammation is reduced. Instead of remaining in an aggressive state, immune cells shift toward repair and maintenance. This allows damaged neural and retinal cells to recover instead of being repeatedly attacked. Balanced immune signaling supports tissue regeneration, synaptic stability, and long-term resilience of both vision and memory systems. Sleep is in another area where inflammation has a powerful impact. Elevated inflammatory markers interfere with deep sleep cycles, which are essential for memory consolidation and eye repair. When inflammation is lowered, sleep becomes deeper and more restorative. This enhances the brain's ability to process information, strengthen memories, and reset neural circuits. The eyes also benefit from improved sleep quality. As nighttime repair processes become more effective, there is also a metabolic connection between inflammation and glucose regulation. Chronic inflammation increases insulin resistance, leading to unstable blood sugar levels. These fluctuations stress the brain and eyes, impairing focus and visual comfort. Reducing inflammation improves metabolic balance, ensuring a steady energy supply to neurons and retinal cells, supporting consistent performance throughout the day. Over time, controlling inflammation changes the trajectory of aging itself. Cells exposed to fewer inflammatory signals maintain their structure and function longer. Neural networks remain adaptable, and visual pathways stay clear and responsive. Instead of slowly losing clarity and sharpness, the brain and eyes retain their ability to respond, adapt, and perform under daily demands, demonstrating how reducing inflammation is not about suppressing the body, but about restoring harmony within its most sensitive systems. Memory is not formed in the moment information is received. It is formed when the brain decides what to keep. That decision happens primarily during sleep, when the brain enters a state dedicated to organizing, strengthening, and storing information. During this time, the brain reviews neural activity from the day, reinforcing important connections and pruning away unnecessary ones. This process, known as memory consolidation, determines how well you remember names, facts, skills, and experiences. Without proper support during this phase, memories remain fragile and easily lost. Sleep is structured in cycles, each serving a different purpose. Deep sleep supports physical repair and neural restoration, while later stages help integrate memories and emotional experiences. For memory consolidation to work efficiently, the brain needs a stable internal environment. Nutritional signals before bed influence whether the brain can remain in these restorative stages long enough to complete its work. Disruptions caused by blood sugar instability, stress hormones, or inflammation can fragment sleep, weakening memory storage. The brain's chemical balance during sleep is uniquely suited for learning. Neurotransmitters that promote alertness decrease, while those that support plasticity and repair become more active. This shift allows synapses to strengthen without interference from external stimuli. When the brain has access to nutrients that support neurotransmitter production and receptor sensitivity, these changes occur more smoothly, enhancing the brain's ability to lock in memories. Energy availability is another key factor. Although the body appears to be resting, the brain remains highly active during sleep. It requires a steady, low-level supply of energy to maintain electrical activity and cellular repair. Slow-releasing nutrients consumed before bed help meet this demand without triggering stress responses. This steady energy flow supports uninterrupted memory processing and reduces nighttime awakenings that disrupt consolidation. Inflammation plays a powerful role in determining sleep quality and memory outcomes. Elevated inflammatory signals interfere with deep sleep stages, shortening the time the brain spends in memory-critical phases. Reducing inflammation before sleep allows the brain to cycle naturally through its stages, maximizing consolidation. This also reduces morning grogginess and mental fog, signs that memory processing was incomplete. Hormones released during sleep further influence memory strength. Growth hormone supports tissue repair, including in the brain, while other sleep-related hormones regulate synaptic remodeling. These hormonal surges depend on proper nutrient availability. When the body has the building blocks it needs, these hormones can strengthen neural connections more effectively, reinforcing learning and recall. The eyes also benefit from sleep-driven neural processing. Visual memory, pattern recognition, and spatial awareness are refined during sleep as the brain processes visual information collected throughout the day. When sleep is deep and uninterrupted, visual pathways become more efficient, improving focus and clarity. Poor sleep, on the other hand, leaves these pathways underdeveloped and strained. There is also a long-term protective effect. Consistent support of sleep-driven memory consolidation reduces the accumulation of toxic proteins associated with cognitive decline. The brain's nighttime cleaning systems operate more efficiently when sleep quality is high, preserving neural health over time. This protection extends to vision-related brain regions, which are vulnerable to metabolic stress. Over months and years, the cumulative impact of high-quality sleep becomes evident. Learning becomes easier, recall faster, and mental endurance stronger, rather than relying on stimulation or effort alone. The brain leverages its natural nighttime processes to maintain sharpness. Supporting memory consolidation through proper sleep is not about forcing the brain to perform, but about creating the conditions it needs to perform naturally night after night.